Okay, welcome to the seventh and final homework video for Chapter 2. So I'm going to do problem 54. And, if you've read the problem, everything is basically in per hour terms. So what I'm going to do is designate, like M100. These are the number of hours, number of hours for, the M100, right? And then the M200, guess what? That is the number of hours for the M200. Okay, so I've got these two printing machines or whatever they are. Okay, so to be honest with you, the task in this problem is just to figure out profit. So first, I'm going to start with revenue. That seemed to be the easiest to me. So the idea here is that the computer company will pay $18 for each case Jackson Hole can deliver, right? Well, for the M100, it has a production capacity of 25 cases per hour. So for the M100, I could earn $18 per case times, what did I just say, 25 cases per hour times the number of hours that I run the M100, right? And then plus, I got $18 for the other one, but now the M200 has a capacity of 40 cases per hour, so 40 times the number of hours that I run that machine, and there you go. So I'll do this over here. So I basically have, and, oh, did I do that right? Yeah, 18 times 40. So I basically have 450 M100 plus 720 M200, okay? So I'll delete that. So that's going to be my revenue. Now I need to come up with my cost. And the cost here is going to be, there are two different costs going on, right? So the first is the raw materials. So the M100 uses 40 pounds of the raw material per hour, right? And that is $6 per pound. And then I have, in addition to the raw material cost, Jackson Hole estimates the hourly cost of operating the M100 and the M200 are $50 and $75 respectively, right? So what I want to do here is, so here I've got $6 per pound of raw material times the 40 pounds of raw material per hour that the M100 uses times the M100, right? And then plus 50 times the M100, because that's the hourly cost of operating the M100. That's 50. So plus 50 times the M100. And then for the other one, it's 6 times 40, 50 pounds. So 6 times 50 pounds times the number, that's 50 pounds per hour. So how long do I run the M200? Oh, plus 75. This costs $75 per hour to run the M200. So for the M100, I am going to have 6 times 40. So that's 240 plus 50. So this is going to cost me $290 an hour for the M100. And then I've got, for the M200, I have 6 times 50. That's 300 plus the 75. So that's 375. It's going to cost me $375 per hour to run the M200. Okay. So then my profit, let me just scroll down one. Okay. So then my profit is the difference. So I'm going to have 450 minus the 290 for the M100. So 450 minus 290. So the profit is going to be $160 per hour of the M100 plus $720 minus 375, or $345 per hour for the M200. So plus $345 per hour times the M200, right? Okay, so this is my profit function. This is what I want to maximize, right? So I'm going to say max instead of profit, right? I'm going to maximize this guy. Now, hopefully, and I do sincerely mean this, hopefully that was the hardest part of this problem, because the rest, I hope you guys would agree, is pretty easy. So for example, there's all this downtime. Because of downtime for maintenance, the M100 will be available for no more than 15 hours, right? So M100 is less than or equal to 15. That's a constraint. The M200 will be available for no more than 10. All right, M200 has to be less than or equal to 10. And then, because of high setup cost, management requires that each machine must be operated for at least 5 hours. All right, so therefore the M100 has to be greater than or equal to 5. The M200 has to be greater than or equal to 5 as well, right? And then my last constraint were the chemicals, right? The 1,000 pounds of chemicals. So, okay, so where is it? So the M100 uses 40 pounds of the raw material per hour. So 40 times the number of hours of the M100 plus 50 pounds per hour. I did that wrong. For the M200, right? This has to be less than or equal to the 1,000 pounds of the chemical that's going to be available for next week. So, there you are. There is your problem in a nutshell. So now what I want to do is, set this up for solver. M100, M200. My parameters, my choice variables, objective function. Okay, so the parameters from the objective function: 160, 345, placeholders, and then the sum product. Okay, parameters, choice variables, voila, done. Okay, 1, 2, 5 constraints. So constraint 1. I'm going to run out of room. Oh well. So for constraint 1, the M100, so this is just 1, 0, and then less than or equal to 15. Try to make these a little bit smaller. Constraint 2, 0, 1, less than or equal to 10. 0, 1, less than or equal to 10. Constraint 3, 1, 0, greater than or equal to 5. 1, 0, greater than or equal to 5. And then constraint 4, 0, 1, greater than or equal to 5. And then constraint 5, 40 plus 50 less than or equal to 1,000. 40, 50, less than or equal to 1,000. Okay. And then, of course, I need to put in my constraints based on my choice variables. So I'll get that sum product function again. All right, array 1 are the choice variables. Array2 are the parameters. Hit OK. Anchor. Okay, copy down. Voila, you are ready to go. All right, so data, Solver. Okay, so I want to, this is my objective function. I want to maximize that by changing my choice variables subject to these constraints. So these two numbers have to be less than or equal to these two numbers. These two numbers have to be greater than or equal to these two numbers. And then finally, this number less than or equal to that number. Hit OK, make sure that's checked, simplex LP, solve. Okay, there you go. So I am going to use, I'm going to use 12.5 hours of the M100 machine, all 10 hours of the M200 machine, and my profit is going to be $5,450. So there we go. That is problem 54. So these are all the homework videos. Now, obviously, I sincerely hope these help. Once you watch the videos, if you have any questions, concerns, or anything like that, please shoot me an email or give me a call at the office, and I'm happy to go through it, clear up any problems that you might have. All right? Well, at any rate, I don't want to take up any more of your time. That is it for this week's homework videos. Have a good weekend.